All right, so we've been using the definition of the derivative, and it basically explains why the derivative represents slope. But fortunately, there are some quick and easy rules that make taking derivatives much less time-consuming. So I've given you a function f of x, and I've given you what its derivative is. So I want you to look at it if you don't remember from last year, and in just a minute, someone explain to me what the pattern is. Okay, we're going to multiply the exponent by the coefficient. So 7 times 10 is 70. And then you decrease your exponent by 1. Good. So 4 times negative 5 is negative 20, x to the third. Technically, this is a 1 right here. So 1 times 3 is 3. And then x to the 0 is just 1. What does it look like the derivative of negative 2 is? 0. And then negative exponents work the exact same way. Negative 3 times 12 is negative 36, but just make sure you decrease your exponent by 1. So negative 3 decreased by 1 is negative 4. All right, so the constant rule. This means I'm taking the derivative of a constant or just a number. The derivative of any constant is always 0. Nice, Emily. I like that. Okay. And the reason for that is if you have the graph of, say, y equals a constant, y equals 5, what is the slope everywhere on that graph? 0. Derivative and slope are the exact same thing. Okay, the power rule, x to the power of n. What would that be in terms of x's and n's? Okay. N times x to the n minus 1. Perfect. All right, what's the derivative of plain old x? 1. And the constant multiple rule is if you've got a function times a constant, then the derivative is just going to be that constant times the derivative of the function. So the derivative of c times f of x is still c times f prime of x. An example of that is, let's say that we're taking the derivative of 5x squared. Well, most of you probably look at that and say, well, it's just 10x. Well, another way to look at it is 5, and then what's the derivative of x squared? 2x. So 5 times 2x simplifies to 10x. So you're just taking the derivative of the variable part and then multiplying it times the constant. You can think about it either way. Find the derivative of g of t and the slope of the graph at t equals 2. Please label what you are doing always, always, always. So the first thing it's asking you to do is find the derivative of g. So I'm going to write that as g prime of t. So what would the derivative be? Good. 8/5 t. And then the slope of the graph at t equal 2 would be labeled as g prime of 2 equals 16/5. Okay? Number 2, find that derivative. I probably want to rewrite this before I start taking the derivative because I want everything in terms of a variable to a power. So how would I rewrite? Okay. So 2t to the 1/2 minus what? Negative 1. Good. Notice that when I rewrote that, I still wrote y equals because that's still y. I'm just rewriting it in a different form. Now when I take the derivative, I'm going to write y prime. So the derivative is going to be what? Good. You can. I heard someone say 1t to the 1/2. That's fine. You're welcome to put the 1 there. All right, what do you think I need to do with number 3 first? Yeah, put the variable on the top. I'm assuming is what the it means. So how would I write this? Okay, I'm good with x to the negative 2/3. It's 1/5 x to the negative 2/3. That 5 is down there on the bottom. There are no exponents attached to that, so I cannot bring it up to the top. remember that when you write exponents as fractions, the top number is the power, the bottom number is the root. So therefore, f prime equals negative 2/15 x to the negative 5/3. All right, the derivative of sine x. Now, does anyone remember this? It's cosine x. Good. Cos x. Okay. And the derivative of cosine x is, man, y'all are good. Negative sine x. Okay, that's true. This is BC calculus. The expectations are pretty high here. There is a proof of why the derivative of cosine x, or the derivative of sine x is cosine x, and that is on, I thought it was wrote down the page. It's in section 2.2, but if you're interested in the proof, you're welcome to look it up. Number 4, find f prime of x. Shall we rewrite this a little bit first? We shall. I like to think of sine x divided by 2 as 1/2 sine x. I would prefer to have a coefficient of 1/2 than divided by 2. Minus 7 cosine x plus x. How can I simplify this parenthesis? Yeah, basically divide everything through by x squared. So 5x cubed over x squared will simplify to 5x, and I'm also distributing a negative. All right, so plus 7x to the negative 1 minus 5x squared. All right, if the derivative of sine x is cosine x, what do you think the derivative of half sine x is? Right, half cosine x. And that kind of goes back to that constant multiple rule where you're just taking the derivative of the trig function and multiplying it times 1/2. All right, what's the derivative of negative 7 cosine x? Good, positive 7 sine x. Okay, what next? Plus 1 minus 5 to the negative 2 plus 10x to the negative 3. Now, ideally, since you've got 1 minus 5, it'd be nice to change that to a negative 4. However, it's not completely necessary, so take your pick. I'm lazy right now, and I don't want to rewrite that whole thing just for 1 minus 5. Okay, this is kind of interesting. We just started talking about derivatives and the easy way to do derivatives, but all of a sudden we're back to a limit. And this is more, okay, well, first off, if I were to just plug a 0 in for h, I'm going to get 0 over 0, right? So that would require foiling out the x plus h squared, simplifying, maybe factoring, blah, blah, blah. I want you to try and recognize this for something else that it represents. Right, it's the derivative formula. It's the limit definition of the derivative for what function? So this limit equals f prime of x, but the big question is, what is f of x? It's x squared. Good. All right, and the reason for that is this is your f of x plus h, and that's your minus f of x all divided by h. So your f of x is x squared. So what this is meaning is find the derivative of f of x. So the derivative of x squared is 2x by the power rule. Okay, so the question wasn't just asking what is f of x. The question is actually asking what is f prime of x, but identify what f of x is and then use the power rule to take its derivative. Easier than foiling all that stuff out and actually doing the limit, right? All right, slope, we all know, represents a rate of change. And we can think of distance as rate times time. And we know that So we know that d equals rate times time. So if I want to think about rate of change, which is slope, in relationship to distance and time, my rate or my velocity can be thought of as distance divided by time. Everybody okay with that? All right, your average velocity. Your average velocity can be thought of as your change in position over your change in time. For some reason, the position function is usually labeled s of t. I'm not sure why they use s. Do they use s in physics also? Okay. So when you see an s of t, it's a lot of times they're talking about a position function. Yeah, so your distance and your position are kind of or you need to think of that as the same thing. All right, so let's talk about average velocity of a particle. So you've got a particle that is starting at A and it's ending up here at B. So this is the position of the particle, or s of t. So this point right here would be A, comma, s of A. And this point is B, comma, s of B. So if velocity is the change in position over the change in time, then the average velocity, your change in position is s of B minus s of A. And how can I represent your change in time? B minus A. Okay, what does this look like? The slope formula. Good. Okay, and so basically slope or velocity is the rate of change of your position. So your average velocity is just the average slope of your position. Okay, so a billiard ball is dropped from a height of 100 feet. If its height in feet at t seconds is s of t equals blah, 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 find the average velocity over the time interval 1 to 2. So I'm given the position. I'm trying to find the average velocity. Well, velocity is nothing more than the slope of s of t. So if I just want to find the slope between those 2 points, so your interval is between A and B. So the average slope is going to be s of 2 minus s of 1 over 2 minus 1. Just using your slope formula. S of 2 is 36 maybe? And S of 1 is 84 all over 1. 36 minus 84, thank you, negative 48. All right, what are your units on this? Feet per second, very good. Because your position is in terms of feet. The top numerator is in terms of feet, the denominator is in terms of seconds. All right, so that's the average velocity or the average rate of change. The instantaneous velocity is found by calculating the average velocity over a very, very small interval. Okay, so I'm going to go back to the same position function. But instead of letting my second part be B, I'm going to call it A plus H. So just some H value. So the slope here, the slope between those 2 points is going to be S of A plus H minus S of A all over A plus H minus A all over H, and I'm writing crooked, but I want to calculate this over a very, very small interval, so I want for that H to be getting closer or decreasing or approaching 0. So I want to take the limit as h approaches 0. Not doing too well. S of a plus h minus s of a all over h, which that is the formula for the derivative. In terms of these variables, it's the derivative of what? S of a. So that equals s prime of a. So your instantaneous velocity is nothing more than the derivative of your position function. Average velocity, you're still having to find the slope between the endpoints of your two on the either side of your interval, but instantaneous velocity is just the derivative.